Welcome to the session on design patterns in the light of lambdas. Well, let me start out by talking a little bit about design patterns. I want to start out by saying I really hate design patterns. That was very motivating, wasn't it? Well, I'll tell you why I hate design patterns. Design patterns are often a reflection of lack of language capabilities. The more patterns we hear usually is because the language doesn't fulfill some gaps that it needs to. What are design patterns though? Hands down, you know that grandma makes the best pie, right? And you've had grandma's pie for years. You have told all your colleagues about grandma's pie, how beautiful, how wonderful she makes, how delicious it is. And then your colleagues tell you, well, if grandma has made such a wonderful pie, you've had it for years, we're going to come to your house on Saturday, you should make it for us. And now you're all nervous, right? So what do? You call grandma and say, Grandma, we got the most important crisis of my life. My friends are coming, I promised to make pie for them, give me the recipe. And grandma goes over the recipe. What does grandma say? Take some flour, take some sugar, put them together. Whoa, slow down, grandma. How much flour? How much sugar? And grandma says, 2, is it tablespoon or teaspoon? You are writing all this. And then when you're done, you ask grandma, Grandma, what are the best practices? You want to know that, right? And you take all this down, and you get up early, and you make the pie on Saturday. And how did it turn out to be? A disaster. The last time I tried it, I lost the spoon with it, right? And then you put it away, you go to the store and get it, and the next weekend you meet grandma and say, Grandma, your recipe did not work. That was a disaster. And while you're talking to grandma, grandma says, oh, don't worry about it. We'll make the pie together. What about that? And you're watching grandma make pie. What did grandma do? Grandma takes a spoon, takes 2 teaspoons of sugar, measures it accurately, and puts it, right? No, of course not. While grandma is talking to you, grandma takes some sugar and tosses it in there and does that. You said, whoa, grandma. What did you do? I put sugar. How much did you put? Enough? But you said 2 teaspoons. I said it because you wanted to know it. Not because, right? Then you realize, how did grandma become so good doing it? Do you know how? By doing it. This is the problem, right? The guys who wrote the design patterns book, the Gang of 4, are the grandmas and the grandpas of our industry, right? And the worst thing they ever did in their life is write the damn book. Now everybody is like, I can do this. And we read it and we try it. There was a story of one guy who emailed one of the authors and said, excuse me, sorry to disturb you, but I have to know this. I've tried every design pattern in your book and I've used it in this code. Except for one pattern. I don't know how to use this one. Can you please change my code to use that pattern? If you ever find this guy, kill him. Get him out of the gene pool, right? Well, the point really is, the goal is not to use a design pattern. The goal is to solve real problems. I find that patterns are phenomenally good communication tool. They're not a great tool for design per se, in my opinion. And the reason is, when I use a design pattern, if I'm trying to fit everything into a pattern, I don't end up focusing on the design quality, I'm getting focused on applying a design pattern. Instead, if I evolve the code and a pattern seems to fit in, then I can use that to communicate. I can say, hey, looks like this pattern is what we are using here predominantly. So having said that, such an encouraging words about design patterns to you, I'll talk about design patterns. So we've been using patterns in Java for a long time. But most of those patterns came from the way Java was as an imperative and object-oriented programming language. But moving forward, we are going to look at how we can benefit from lambdas, because lambdas can serve as a really good design tool in getting our work done. So lambda expressions can be now used very fundamentally, and we can mix and match what we do already, imperative and object-oriented, with this style as well. To talk about that, let's talk about the iterator. The iterator pattern shows us how we can start iterating over collection of data. We are used to external iterator in Java so far. So for example, if we have a collection of values given to us, and if I want to iterate through these values, I could have said for int I equal to 0, I less than numbers dot size I plus plus, and then I could say output, in this case numbers dot get I, for example. That's a verbose piece of code. But rather than doing this, we already have something simple in Java, right? We could have said for int element coming from numbers, and then we could output the element. That's a lot simpler than the previous one when we didn't care about the index value. But the beauty of this is we have yet another way to do this. We could say numbers dot for each in this case, and we could say given an element, I want to output this particular element. We could write it this way. Or you could go even an extent and say, given numbers dot for each, I can say system dot out, and then of course use a method reference and println, and we could write this. So moving forward in Java 8, we got a bunch of different ways we can do things. We could use the good old traditional for loop. We could use the for each, or we could use an internal iterator. And so the iterator pattern can be applied to iterate over a collection, not only through an external iterator, but using an internal iterator as well. And we can mix and match based on what our needs are, depending on the situation, depending on the condition, we can decide how to go. But moving a little forward, we can use this as a lightweight strategy. What does it mean, lightweight strategy? Let's take a little problem to work with. So let's say for a minute, you're at work on a Friday, and you've been waiting eagerly for this wonderful party that's going to happen. You've been talking about this for a while, and you're just absolutely all geared up to go to this party. You want to leave early to go to this. But unfortunately, one of your colleagues comes to you and says, I need you to write a function that will take a collection of prices and total it, right? Imagine these are price values. So you're in a rush. You say, okay, I'll write it for you. So you say output, total values, just to try it out. And I'm going to give the numbers. How are you going to write the function total values? Well, public static total values takes a list of integer, we'll call it values. And what am I going to do with this function? Let's say int result is equal to 0. I want to return the result, right? That's what you're going to do over here. And then what do you do in between? For int element coming from the values, result plus equal to the element. You got it working. And now you think back at, I'm ready to go to this party. When your colleague, the one who nags you all the time, right? You know whom I'm talking about, comes to you and says, wait a minute, not so fast. I need one more function from you. Not only do I want to total all the values, I want it, but I also want to total all the even values. And you ask your colleague, you mean I need to have this total values, but I also need to write you a function called total even values. And your colleague says, yep, that's what I want, and walks away. You look at your watch and say, you know what, I really want to go for this party. I don't want to be at work any longer. And you look at the code, and you realize something wonderful. It does almost everything you wanted. Almost. And you look at your watch and you tell yourselves, there's got to be a reason why they created copy and paste. Right? I mean, think about it. If no one should use copy and pasting, why would they create it? Right? So you're like, this is awesome. And then you quietly change it quickly. Even values. And then you say, if e mod 2 is equal to 0, then total not otherwise. It worked beautifully. And you're about to get up from your chair when your colleague walks in and says, excuse me, I need one more help. What now? I want you to total odd values also. Are you kidding me? No, I need it now, and walks away. Now you're really angry. And you know one thing, copying and pasting a code a third time is an act of criminal negligence. But it's Friday evening and nobody's watching. So you make a copy one more time, right? And you say not equal to, and it worked too. And then you drive away. On the way, guilt kicks in. And you said, that's not what I geared for, I prepared for. So you pull up the nearest coffee place and you frantically refactor this. But as fate may have it, some of your other friends who are hanging around come over and say, what are you doing? And before you could respond, before you could close your laptop, they look at your code and they discover your dark side. They get to know that you do copy and pasting for a living. They no longer return your phone calls anymore. They don't respond to your text messages anymore. How life becomes dark, isn't it? So let's pretend this never happened. So back at work, Friday afternoon, you really want to go to this party. You're sitting and working, your colleague comes to you and says, hey, I need a favor from you. What do you want? I want you to create a function. What function do you want? The one that totals all the values. And you just created it. Great. Then your colleague walks in and says, I need one more function from you. What do you want? I want you to create a function that will total all the even values. You mean you want two functions, one that creates total and the one that creates total of even values. And your colleague says, yep, that's what I want, and walks away. You say, okay, let me take a stab at it. So you're going to walk back and do a little refactoring. You're going to say, I am going to come in here. Had I written these three methods, the only difference was that one little thing in the if within the function. So what I'm going to do here is, I'm going to say if selector test E. If the selector is happy with the value, I will then total it, not otherwise. Okay, then what do we do? How do we call it? When I call the method, I'm going to say given an element, return true. So I'm going to pass a little lambda expression here to the call. So this says, I don't care what element you give me, I'm going to return a true. This says, if the selector is happy, I'll add, otherwise I'll skip it. That brings up the question, what is the selector? Well, I'm going to bring in java.util.function.star, and I'm going to define the selector as a predicate which takes a type integer and use it. So you can see the code was able to transform this and provide the value. Now what we can do is simply reuse the function and say if E and E mod 2 is equal to 0, that's totaling only the even values. A few minutes later, your colleague comes to you and says, I need to total odd values. You tell your colleague, go back to your desk and do it yourself, because I made the code more reusable for you, so you can do that without me having to write more code. If you really think about it, what did we just do? We wrote the function total values, which is doing all the general work, except we took away and extracted from the function a little logic. When I had the duplicated parts, all the three functions were self-contained. Each function did almost the same thing, except for that one little part that was different in each of the function. We just took that one different part and extracted it into the parameter list. That idea we have seen before. That is called the strategy pattern. In the old version of Java, if you want to use strategy pattern, you would normally call for a corporate design meeting. Here, just get it done because it's so lightweight. So Lambdas can serve as a nice strategy for you to use, and that's what we just did here. So by extracting that one little property that differentiates one value from the other, we were able to remove that out here. But the beauty of this is now, we can also refactor this code into a more functional style. If you look at this code, what is it doing? Well, that code says, given a collection of values, I want to select certain values from the collection, and then I want to total them. Well, if that's what we are doing, we can rewrite it. And the way we can rewrite it is, we can say return values.stream and filter. And in this case, I can say given an element, well, we already have what it is, a selector. So just pass the selector because filter takes a predicate. You have a predicate which is the selector, so just pass the selector to filter. Then you can say over here, reduce, we start with a 0, and we can say total comma element, and we can return total plus element from this. So in this case, we are performing the same operation. Or we can write this a little differently. We can say reduce, and given a total and an element, we can say integer.sum total plus element. So we can rewrite that a little bit different too. Or we can say, well, because it's calling a sum, rather than putting so much effort, we'll simply say integer colon sum and just pass it down there. We could do that too. So we can start refactoring code quite a bit by using the Lambda expressions, and we can make use of how to make the code more expressive. So in this case, what we have done is we have said, given the values to total and the selector, which is the strategy, I want to take the collection, filter out elements that I care about, and then I would, of course, reduce using the sum operation and return the value. There's more than one way to do this, but that's just one example. So that's an example of how we could make use of the strategy pattern. This is something we can go quite far into making use in code by bringing these together. We can also use lambdas for delegations as well. Lambdas give us a nice way to perform lazy evaluations. Now, when it comes to lazy evaluations, there are some really interesting things we could actually do that can be really fun. If you think about some things like this, let's take a little example and play with it. If you write a code in Java like this, where let's say we have an int x equal to 4, and I'm going to have a function called compute. So I have a public, let's say, static, and int compute, and this is going to take a value, and let's say it simply returns a value times 2. Not a whole lot, right? But I say if x is greater than 5 and compute of, let's say, x is greater than 3, then I want to print out result 1. Otherwise, I'll print out, for lack of better words, result 2. So that's the code. But I'm going to run this code. But before I run this code, a question to you. Will compute run or not in this example? No. Why not? Compilation error? Where did I make a compilation error? Line number 5. What did I do in line 5? Missing what? Now, will compute run or not? I fixed it for you and you're still saying no. Why did you bother to fix it then? So it won't run. Why? What's the word? What, did I make a mistake again? No. Short circuiting. Everyone understands short circuiting, right? You learn short circuiting very early in your programming career, right? And you know if there's a short circuiting, it will not call the function. We all know this. Absolutely. So let's see if that's true. Run it. So John McCarthy was the guy who invented this idea of short circuiting when he wrote Lisp. Let's rewrite this. I'm going to say temp. Int temp equals compute. Will compute be called? Should compute be called? I hear a few yeses and a many no's. Let's try it again. Should compute be called? No. Why? It's useless. It does all the work. What did you do after it did all the work? Throw it away. Who wants to do that? Not even if you work for the government, right? So no, that's a waste. Total waste of effort. Why do it? Unfortunately, as you said, it's going to go call it, right? So when you run it, it did call it. What a sad, sad, sad code. Well, if you were to write this code in Haskell, it wouldn't call it. Haskell says, gosh, you never used it. I'm not going to call it. Different languages do things very differently. So let's take one more example just for the fun of it, right? So here is an example Scala code I'm going to use. In fact, I'll just take the code we just wrote and rewrite it in Scala, right? So let's go ahead and just grab this part, just bring it down to Scala. I'm going to be lazy to just bring it here. And here is the function compute. It takes a value, which is of type int, and it says, I'm going to return value times 2. Well, actually, let's do it this way. So if I go run this way to prove that it's going to be being called, so output called over here, so we can actually see that it's called. And then, of course, once I do this, I'm going to return the value times 2. That's just our compute method. So back here, I'm going to say x is a value of value 4. And I would say, let's say if, let's actually get rid of this for a second. Let's say if x is greater than 5 and compute of x is greater than 3, I'm going to println result 1, else I'm going to println, let's say, result 2. So that is Scala code, right? And if I run this code, what does it do? Well, in this case, it's not console. Where did I put console? Sorry, println, right? So println, and I'm going to write this particular output. There we go. So it's not calling it. Awesome. But if I take this code up here, and I say temp, like I said, Haskell wouldn't call it. But I say temp equals compute. But sadly, Scala called it 2, right? So you're like, So Scala called it 2. So if I say compute here in Java, Java called it 2. Why does the language do this? Why it's not smart enough to avoid it? Language like Haskell, everything is pure unless you say that it's not pure. Language like Java and Scala, everything is impure unless you say it's pure. Look at the opposite ends, right? The default here is purity. The default here is impurity. So you're living in two different worlds in this case. When everything is pure, the compiler can optimize things. When everything is impure, the compiler is like, don't touch it, right? So in this case, the compiler said, if I don't run that, you'll be upset. Hey, why was I not upset here? Because I taught you that very early in school. That you know that if it's short-circuited, it won't be called. Even if it has side effect, that's the way it is. So you say, okay, Scala, I get it. But I do really mean it. Don't do work that's not needed. Lazy. By marking it lazy, you can avoid running that particular call. So without the word lazy, it ran it. With the word lazy, it skips it. So you can kind of mark some variables as, that's okay, I don't mind if you don't call it. Well, that would be so cool to do here, isn't it? So what if I said lazy right here? No, it doesn't work. So, but how can I be lazy? Lambdas give you an ability to be lazy. What do lambdas do? Lambdas are functions, really, anonymous functions. So rather than calling a function, you pass a function that will be eventually called, but only when it's needed, right? So what I can do here is I can do the following. I could say supplier integer temp is equal to, and I can wrap this into a lambda. So in this case, the supplier says, I am going to give you the result of compute. But look at the line that's highlighted, line number 12. Line 12 will not execute the lambda right now. It is just holding on to a lambda. Then I can say temp.get and not otherwise. So notice that's not calling it. But if I said x is greater than 1, you can see it's calling it. So the point really is you can achieve laziness using lambda expressions. In fact, lambdas often are used for lazy evaluation. So there are two kinds of evaluations, eager evaluations and lazy evaluations. Lazy evaluations give us the ability to postpone computations. The benefit of doing that is we're not dragged into doing work eagerly, and by postponing it, we can gain on performance because we can avoid doing things. We can apply these ideas to postpone object creation. Something like a virtual proxy, for example, we can apply that. So what we can do is, rather than holding on to an object, you can hold on to a supplier. And then only when the object is needed, you can use the supplier to create the object. Then you can say, don't be in a hurry to create this object, wait until a later time to create this object. So this can be a really powerful way of doing things. For example, suppose you had a class, let's say class A, and the constructor of this said, B, and I'm going to pass an instance. In this case, whether you use B or not, you're going to create an object of B to pass to this. You don't have a choice at this point, right? So in this case, if I'm going to call the object of A, I would do something like this. I would say A, object equals new A, new B. What if B is never used by A? Sorry, you wasted this object B. What if creating this B was expensive? Tough luck. You had to spend that expense whether you needed it or not. Let's turn this around. Let's go back here and say supplier of B instead of B. Then what do you do here? A parenthesis that. Now you're saying, I'm going to wait until A really needs the object B. If A doesn't need the object, I would never create it. But the time when A needs an object, I'm going to create an object of B and give it to it. So this is again a lazy evaluation. So you can delegate the responsibility of creating the object to the supplier, and by doing so, you can postpone object creations. And that can save you a lot of effort in runtime by delaying object creation to the point when you no longer can avoid creating the object. Some ideas to toss around. But let's go a little forward with this. I want to use a decorator pattern. If I use the word decorator pattern in Java, does anybody have something that comes to your mind where you may have seen a decorator pattern, a traditional example? Yeah, file input stream, new, buffered input stream, new, file input stream, new. How do you feel about that? Remember the day you read about it and you said, oh my gosh, this is not a decorator pattern. What is the purpose of decorator? To make things beautiful. You should be saying, wow, this looks better than what it was. In this, you decorate, it looks uglier. And then you wonder, you went to the dictionary and said, what does decoration mean, right? So it didn't decorate it, it made it uglier than it was, right? And then you're like, why bother? And we kind of ignored it, right? Never bothered to really use it. But the reason is it's too verbose. Let's try this a little differently. Functions can be used beautifully to decorate. But before I talk about it, I want to show you one quick thing. If I create a function, and I'm going to say integer, comma, integer, and I'll call inc equals, given a value, value plus 1. I'm going to create another function. And this function is going to be double it, given a value, value times 2. Now I can call a function which is going to use this. I can say increment. Let's actually call a function here. So let's go ahead and say public, static, let's say void, use function, and I'm going to pass a function to it. So function, and integer, comma, integer, we'll call it func. And what I'm going to do here is output over here, func, so in this case, func.apply, let's say a value of 4. Let's try this. So I'm going to call the function use function, send inc to it. What is that going to do? Take 4 and increment it, right? So that became 5, sure. Use func, and I'm going to pass double it. What is it going to do? Take 4 and double it, which becomes 8. But I want to do both. Here comes the charm. Inc, and then double it. So you can start combining functions together very nicely. Increment 4 becomes 5. Double it becomes 10. So you can start combining functions really well. Well, if I know how to combine functions, I can make use of this to do some pretty interesting things. Let's look at an example of this. But before I start this example, a word of caution. If you're not wearing your seat belts, I recommend that you buckle up your seat belts. If oxygen masks come from the ceiling, Put it on yourself first before you assess the person next to you. Are you ready? I know you're all tensed up. You're all like so brittle now. If I just touch you, you're going to break. No, just kidding. Let's try something else. Let's create a class called camera. The camera class has a method called snap. What does the snap do? Takes a color. We'll call it input. And what does that do? It returns the color. That's the output. That's a silly example, but let's start with that. So java.awt.color. We'll start with that example. So what do I want to do? In this case, I'm going to do a snap. Given an input, I'm going to give you an output. Let's start with something really, really simple. I'm going to just return what you give me, input. So we'll say here, public static void print snap. It takes a camera on our hands. And we'll come back and pass one more data in a few minutes. We'll come to that in a second. Output camera dot. What do I want to pass to it? Snap. Let's say new color. 125, 125, 125. You know what the result of this is going to be, right? So we'll call print snap and pass new camera to it. And it better be giving the same input as the output really is. That's what we are expecting. So when I run this little example, what does it do? Okay, this is a little bit annoying. So I'm going to run this from the command prompt so we don't have to worry about this one here. So we'll come back to that. So let's go to the command prompt and play with this. So I'm going to go to the directory where I have this stuff. I'm going to just run it from there. So that way I can run it a little bit more easily than from the tool over there. So let's just make our lives a little easy. Here is the dot run, and I'm going to run it. So you can see that it printed 125, 125, 125. Okay, that worked. But I want to apply some filters to this camera. So when you take a snap, I can apply a filter. Well, to apply the filter, what I'm going to do is I'm going to bring in a function. So this is going to be a dot function right here. So now I'm going to go back here and say a private function. This takes a color as input and returns a color as output. I'll call it a filter. The word filter here is not like the filter in the stream. It's a filter like in a camera filter. So I'm going to apply some filters. So what am I going to do? I got a filter. But in this case, I'll call it filters for a minute. But when I create a camera, so here is the camera object. And to this camera object, I'm going to pass a function, color, comma, color, for the filters. But I want to be able to take 0 or more filters. What can help me to pass 0 or more objects? Right? That's right, params, variable arguments. So we can pass that. So now let's just start with baby steps. I'll say filters is equal to, given an input, give me an output. This is a filter which doesn't do any filtering, right? Just passes the data through. We'll start with that little example. So that's a default. And I do create a camera right here. And that's going to just pass it through. What am I going to do here? I'm going to say return filters.apply, apply, given the input, give me the output. So once again, let's just go run this from here. Oh, wait a minute. It's saying unchecked warning. It complains about a warning here. On line number 8 and line 23. This is a wonderful feature of Java, right? You should try this if you haven't tried it. You say suppress warnings. Isn't that a beautiful feature? Unchecked. I love this game we play with Java, right? It'll tell you I don't like this. And then you say, do you like this one now? And the Java says, oh, you and I are such a good friends. I like this. We can do that. Unchecked. So what did I do wrong here? This should be given as unchecked. Suppress warnings. Of course, why suppress one warning when you can suppress many of them? That'll be even better. So let's try this. And that gave us the same result. Cool. Now going back to this. Again, we just got an input and return an output. Didn't do a whole lot, right? All right. But now what do I want to do? I want to go back here and say print snap, new camera. But to this, I'm going to say given a color, return color dot brighter. That would be cool, right? To take the color and make it brighter. So the first camera said, don't bother, just give me the output. The second camera says, I'm going to take whatever signal you give me and make it brighter. How do we do this? Well, let's change this a little bit. How about color brighter? We could even use a method reference. Well, in here though, you gave me a filter right here. Can anybody tell me what is the type of this object the filters is? It's an array. If it's a list, I can do .stream, isn't it? But it's not a list, it's an array. Stream.of the filters. That's how you iterate over an array of values. So I'm going to bring in the stream. Now that I have a stream of filters, what do I do next? You have a collection of objects, but you only want one object that you're going to compute based on all these objects. What method is useful to do this work? Reduce, that's correct. We can use reduce. So I'm going to say dot reduce. The first one you're going to give is, given an input, give me an output. Then you say, given a filter, the filters that you're going to get back, comma a filter. What am I going to do here? Filter dot and then a filter, right? So you're going to combine the filters together, and when you're done with it, you're going to assign it to filters. So filters is equal to, you take the collection of filters and you reduce it using the and then. So what does this do? If you didn't give me any filters, the array is empty, then the filter I have is converting input to input, which is the default. If you give me multiple filters, then I'll combine the one that converts input to input with that other filter, the second one and the third one and the fourth one, right? That's all I'm going to do. So if I run this code, notice it's brighter than what we gave it before. Let's try this one more time. I can then go back here and say, run this again this time, but I'll make this darker. So if I go back and try this again, notice that it's darker than what I gave earlier. Instead of 125, it's 87. You could, now that you got to that point, you know where I'm going with this, I could, don't ask me why, but change it to brighter and change it to darker. Notice how you can start decorating multiple functions together. So this could be a series of transformation you want to perform, but let the caller decide what series of transformations to apply. So this could be some data that you're dealing with, and then you can say, here is the filter 1, filter 2, filter 3, filter 4, but as a caller, I can pick and choose the filters and the order in which I want to use these filters, right? So in this example, when you run this, notice how that made it brighter and darker. We lost a few in the transformation. One small detail, we can make this a little bit more concise. We can take this code and say, well, that is reduce, of course, but rather than doing so much work in the reduce, we can say reduce. This is taking an input and returning an output. That has a special name, a special function. It's called function.identity. That's the name of that function. Function.identity, comma, look at this guy. Given a filter and a filter, you call and then on it. So that becomes a function and then. So notice the conciseness of that code and how that becomes a lot less work. So you can rewrite this function like that. So extremely concise, isn't it? Maybe it takes a little effort to understand, but what it does is you are taking this collection of filters and you have reduced it into a combination of these filters. So essentially you said, given these discrete filters, I have taken this filter and I've combined it to the next one, and I've formed a chain, and then I've combined it to the next one, and you got this chain of filters. And now what you have with you is this little filter you're holding here, right? You're holding on to only one filter, right? But that filter is connected to the next one, and the next one, and the next one, and the next one, and you got a pipeline of these filters. Once you hold this pipeline, you send the data here, it transforms through and gets on the other side, and you're building a pipeline. This is exactly the idea behind fusion as well. When you put multiple filters in the stream, filter map, they're going to fuse it together. So they will take these different values and combine it to one and say, that's a chunk I want to use, and they can bring it together. So that's basically what you're seeing here, is you can apply the ideas of functions and how you can combine them. The same thing applies to predicates as well. Predicates also have functions like and, or, and things like that, which you can take and combine too. And so that gives you an interesting way to use a decorator pattern, but in this case using lambdas or method references, right? Where the lambda is really simple, you could use a method reference as well. Moving forward, let's talk about one other pattern which we could really make use of. So for this, I'm going to take a different class here. This class is going to have a few issues, and we will iron that out with this example. So let's say we have a class called mailer. So this class mailer contains a bunch of functions. The first function it contains is a function called from, where the from function takes a string address. And all I'm going to do is output from here. And I got a few other functions. I got a function called to, which is going to simply print to. I got a function called subject, which takes a line, and it simply says subject. And I got a function called body, which takes a message, and it simply says body. And then finally, I've got a function called send, which doesn't take anything, but it simply performs sending. So let's talk about how to use this particular code. Well, to use the code, I'm going to say mailer is equal to new mailer. Then I'm going to say mailer.from. And where is this coming from? I'm going to say builder at agiledeveloper.com. So that's where the builder is going to send me an email. And it's going to send the email to my address. So I'm going to say here is my address. And finally, there's got to be a subject to it, right? So subject. This is a subject that my mailer usually likes to send my messages to. It says, your code sucks. And then it says mailer.body, and it tells how this code actually sucks. Details, right? And then, of course, finally, to send out the email itself, I could configure it to say mailer.send and send it. Well, while the code works, there are two problems with this code. The first problem is noise. It is very verbose, right? And noisy. So it's noisy. Second, do I reuse the mailer instance after this call or not? Let's talk about those two problems. The first problem is it's noisy. That's a lot of noise in the code. And the second problem is, should I reuse the mailer or should I not reuse the mailer, right? Let's fix the noise problem first. Then we'll talk about the problem of the mailer being reused. One way to fix the noise problem here is by making a slight adjustment. Take each of these functions. They're returning a void right now, as you can see. Rather than returning a void, let's return a mailer. So every one of these functions will return a mailer object, which means in the end of this function, rather than being a void, they return a this. So every one of these functions is going to return the current object itself, right, after doing the work. The code still works, but it's still noisy. But what we can do here is, we can remove this mailer, and we can remove these semicolons, and the code still works. So we can transform the code to take the result of the from, and call the to and take the result of the to, and call the subject and take the result of subject, and call the body, and so on. This addresses the noise to some extent. It's not as noisy anymore. We're not constantly saying mailer, mailer, mailer. We could even go to the extent of not even saving this mailer object, and we could just concatenate it from the mailer we create here, and that would be fine as well. But unfortunately, this question is not answered yet. Should I reuse the mailer or should I not reuse the mailer? If you should reuse the mailer and you don't, that's a waste of resource. If you shouldn't reuse the mailer and you do, that's an error. So how do you know what the answer is? Short answer, we don't know. Read the documentation. How did it go for you the last time you tried to read the documentation? It only made more frustration, right? So there should be a better answer. What if I don't have to worry about it? What if the user of the class don't have to worry about it? What if that's something that the author of the class can decide? Well, here's an idea. Let's go back and say public static void send. And I'm going to turn this into a static method. Then within the method, I'll say mailer is equal to new mailer. And I'll say block.accept mailer. Well, it's not complete yet, but start with this. The send method says, I am going to say new mailer, create an object. I can, as a person writing the send method, I can decide what to do here. I can either reuse the mailer or I can create a new one every time. That's my choice, right, as an author of this class. You, as a user of the class, don't have to worry about it. So I have a mailer object created, and I pass it to some block. We don't know what that is. And then when you come back from this call, I'm going to call the send method. Well, but how do I use this now? Well, this is going to require a block. So I'm going to pass a block here. For that, I'm going to bring in the function.star, and I will use this called consumer of mailer. We'll call it block. So now you can see that we are receiving a consumer and then creating a mailer object and passing it to this consumer. As a result, I can now say mailer.send. In here, I can receive the mailer, and then I can simply say over here, mailer dot from to subject, everything except the send, because we moved the send up there. So you can see how the code now works, but in this case, we turned it around a little bit. The send method says, you don't worry about object. In fact, I'll go a step forward. I will make the constructor of this class private. So now you cannot even create an object of mailer. You're forced to use the send method. So you call the send method. The send method will take a consumer, a block. It will create a mailer or reuse a mailer and call your consumer, passing in the mailer. Let you do your work, whatever you have to do. And then when you're done with it, it takes on the mailer that you created and configured and uses it for other purposes. So this can be a very nice way. And what we're doing here is we are creating a fairly fluent interface, and you are eliminating the things like new, and you remove the decision of creating an object from the user of your class to the person who is creating the class itself. So your life as a user becomes more streamlined. You don't have to worry about whether to reuse the object or not. If you shouldn't reuse, that's not your problem. They're not reusing it. If it should be reused, that's not a problem, your problem. Because they will, instead of creating a new object, simply reuse an object and return it to you, so you don't have to worry about it. So we can start creating somewhat of a fluency when it comes to these kinds of code, thanks to lambdas. So these lambdas are this newfound tool, right? That now that we have lambdas, we can use to solve problems with lambdas because they are fairly elegant, they're very concise, they are anonymous functions, and rather than just using classes, we can start using lambdas also in different ways. To show this, I'll use one final example for you. This is one of my favorite patterns. I've used this quite extensively in different languages. This is a pattern from quite a long time. It's a pattern from the smalltalk days. Ken Beck has a wonderful book where he talks about this pattern and other things called the Smalltalk Best Practices. So I came across this pattern there, But I've seen it in a few other languages also. But now that Java has lambdas, we can use this pattern. So to understand what we can do, I'm going to give you a series of examples here. So let's start with a problem at hand. I have a class called resource. The class resource has a constructor, and in the constructor I'm simply saying created, right? That's all I did. Then I have a function, we'll call it as op1, which is going to output right here, op1, and it returns this. Similarly, I have an op2, some operation 2, and this is saying op2 and returns it. But finally, I have a function which is finally, finalizer, right? Finalize, and what does this do? Output clean up. So now, I'm interested in trying this out. So resource is equal to new resource, right? I create the object of resource. The solution is going to look a lot like what we just did, but the intention is different. Resource.op1 and resource.op2. I'm going to run this code. When I run this code, will the finalize be called or not? Yes? No? Here you go. Yes? No? Come on. No, I see a few people. There's few hands this way and a few hands this way. And I see a few hands this way. Right? They're like, I don't know. I'm not sure. Sorry? Unpredictable. You got to be a consultant. Right? Because the standard answer consultant is, it depends. Right? That's what we do. So, it depends. So, unpredictable. Line number 5. What did I do wrong in line 5? Where did that come from? Okay, output. So, in this case, of course, I run the code. It did not call it. Why? Well, maybe I mistyped the word finalize. Let me check. F-I-N-A-L-I-Z-E. No, that's right. Well, it turns out the garbage collector in Java is kind of like the garbage collector in my neighborhood. They say, Venkat, let him have his trash. We'll collect it next week, right? Well, the garbage collector says it's automatic but not instantaneous. Automatic but not deterministic, right? It says if there's a lot of memory usage, if we need memory, we'll come and collect it. If you have a lot of memory, why bother? So this reminds me of a project I was called into. This client called me and said, Venkat, come over, do code review. The manager said this. And while you're doing code review, maybe you can help us fix a problem we've been having for a few months. That's what the boss said. So my question was, boss, well, what's the problem? He said, I don't know, go talk to my programmers. So I went and asked the programmers, I was told you have a problem, what is it? And nobody would tell me what the problem is. I mean, how do you go find a problem, nobody tells you what it is? But then finally I came across one developer said, I was told while I do code review, I had to find a problem. Can you tell me what the problem is? He said, oh, yes. Our program works fine most of the time. I said, that's good. Can you tell me when it doesn't work? Oh yeah, it doesn't work between 7:15 and 9 in the morning. I said, oh my gosh, every day this happens. No, only Monday through Friday. It works fine on Saturday and Sunday. So I was like, this was not helping me at all. I said, thanks, that was very helpful. And then I kind of ignored it and started reading the code. And when I started reviewing the code, I came across this class. There was this class, and it had a constructor, and in the constructor, they were creating a database connection. You know where this is going now. And in the finalize method, they were releasing it. And the minute I saw this, oh boy, I know what's going on here. This application was running in a portal. You know what happens in big companies between 7:15 and 9 in the morning? Everyone logs in. And they use the portal, whether they like it or not. Guess what's happening on Saturday and Sunday? Not many people are showing up to work. So I'm like, damn, this is what is happening. So I went to the team and said, I think I know what the problem is. You guys are using finalize. So what I did was, I quietly changed the finalize to close, and I came and called close right here. And I said, run it. And this guy who was sitting there in the corner quietly watching me, he was sitting and monitoring the database connections. I didn't know this. And we make this change, we run the code. And while he was eating his pizza, I said, it's like, yeah, what's up? You fixed the problem. I said, how do you know sitting over there? Because all day I've been monitoring database connections. And it goes up and stays there. And you put this fix, and now it's over here. So it's fixed. I was like, okay, this is cool. But the real fun part was that afternoon, after lunch. The boss comes back from lunch. And the team, one of the guys said, oh, we got some good news for you. What is it? Remember the problem we've been having for months? Yeah, we fixed it. He was like, wow, what did you guys do? Oh, Venkat asked us to add this one line, call close. And the problem is gone. Oh yeah, it's gone. What else did he do? Nothing. He just added this one line, the problem is gone. And there was a pause, and then I heard him say, have you only added one line? Do we still need to pay him? Well, it turned out there's a little bit more here, right? Because this is not going to fix all your problems. Something could go terribly wrong here too. What is it? That's right, thank you. What if this guy throws an exception? Now, there are some problems with this code, right? First is, close is unpredictable. Don't want to do this. But now, you may forget to call close. Is that true? How many of you may forget to call close? The others are lying, right? In fact, they forgot they would forget it. This is meta. Okay, yeah, we'll forget it. Forget to call close. Second, exception you said. Oops. Okay, let's try this to fix it. I'm going to say try, and then I move this here, and I will say finally, and then call close within this. Now what happened? You may forget to call close, try, and finally. Isn't that true? This only became worse. Second, this is verbose, isn't it? So the problem only became worse. We got to find a better way to solve it. Good news. Java 7 has what's called ARM. It is called Automatic Resource Management, or also known as try with resources. What does that mean? We're going to say, we'll make this less verbose, try like this. Then we don't have to put this try. We don't need the finally anymore. We will move this into here. Isn't that beautiful? We won't work right now. But for this to work, we got to say implements auto-closable. The beauty of this is, notice when you leave the block of code, it automatically calls the cleanup. That's a good news, right? What's the good news? Would you all agree that it's less verbose than a minute ago? Yes. Did it cure the forgetfulness problem? No, because the question is, what if I did not put the try? Question for you. If you don't put the try, Java will complain because you have auto-closable. It will give you an error over here, true or false? False. It will give you a warning, true or false? False. But you know this already. What is it? Never trust a feature with the word management in its name. So that didn't work either. So we got to do something different, isn't it? Something that will give us the result and not just blame on us and say, you forgot it, right? How do you get to that point? So here's an idea. What if we don't let the programmer forget? You tell the programmer cannot forget doing this. Why? Because we're going to do it for you. So here's the close. This is wrong. We shouldn't do this. Let's take the public and make it private. The programmer says, oh boy, I cannot call this function. Why not? Because it's private. So what does the programmer say? Okay, I won't call it. That didn't fix the problem, really. Let's take the constructor and say private. Now you cannot even create an object. They're going to say, what gives? I can't even create an object. What's the magic here? Well, here's the magic. I'm going to say a public, static, void, use. And within here, I'll say resource is equal to new resource. I can remember to do this as a person writing this class because I know resource is intensive and I need to manage it, right? So I'm going to say resource.close right here. But then, applying the thing we did in the last example, block.accept, and I will pass to it the resource, where this becomes the consumer of resource. I'll call it block. Look at the beauty of this though. You cannot create an object, you cannot close it, but you can use it. There's an execute around method pattern. Before you use it, I'll create it. After you use it, I will clean it up. But in between, I'll give you an opportunity to use it. So now what I can do here is, I can say resource.use. Given a resource, I want to say resource.op1, .op2, and when you're done, leave it. So now when I go back and run the code, you can see that it performs a cleanup automatically. So we can nicely use the lambdas to give a context of execution. This is called the execute around method pattern. So you come and do some pretty work, yield control to the user, they do whatever they want to do, and then when they return, you perform the cleanup operation, a very powerful pattern that you can use for various different concepts. You can bind transactions in this context. You can bind operations that require open and close in this context. You can bind operations that require a pre and post stop in this context. So what we saw was how we can make use of lambdas to use in some design patterns, so to say, and how we can make use of everything we had before in Java, but then some more as well, thanks to Lambda expressions. Hope that was useful. Thank you.